In this video, I will show you how to solve a variety of trig equations, including some that involve double angle identities. All right, this little statement right here means that we want to find all of the solutions between 0 and 2 pi, so no negative answers will be allowed. And if we have a choice between 0 and 2 pi, this bracket means we're going to call it 0. So for this one, all we really need to do is to get the sine squared part by itself. So I'm going to add 3 and divide by 4. So that's immediately going to give me sine squared x is equal to 3 over 4. Then to unsquare things, I need to take the square root of both sides. Never forgetting that when you take the square root, the solution can be positive or negative. So put a little plus or minus on it. So now I have sine x equals plus or minus, and this will be radical 3 over 2, I meant to say. All right, so this will be radical 3 over 2. Now, ignoring the plus or minus for a moment, the sine of what angle is radical 3 over 2? You should be thinking pi over 3. Right? That's the reference angle. All right, the reference angle is pi over 3. And I'm assuming you've memorized these. So when you see the sine and it's radical 3 over 2, you should automatically be thinking the reference angle is pi over 3. But sine is positive in 2 quadrants and negative in 2 quadrants. So we actually want all 4 quadrants. All right, this is a reference angle of pi over 3, and these are the 4 angles that have this as a reference angle. All right, so all 4 of these will give me either positive or negative radical 3 over 2. Okay, and this one, of course, is pi over 3. Over here on the far left, pi is the same thing as 3 pi over 3. So that means this must be 2 pi over 3, 3 pi over 3, and this must be 4 pi over 3. All right, 2 pi is the same thing as 6 pi over 3, so this must be 5 pi over 3. So these are the 4 solutions. Okay, I'm just going to recopy them. So x is equal to pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Number 23 looks like it's going to be a factoring problem, but first, I don't like the fact that I have 2 different types of trig functions. I have secant and I have tangent. So I really want to rewrite these so that I have just one trig function. So I'm remembering my identities, and you have to have these memorized. So secant squared is 1 plus tangent squared. So I'm going to make that substitution right now. So instead of secant squared, I'm going to have 1 plus tangent squared. Okay, and then minus tangent to the 4th power is equal to -1. All right, now it's all tangent, so this should be doable. If I do the distributive property here, that's going to give me 2 plus 2 tangent squared minus tangent to the 4th power. Might as well go ahead and add 1 to both sides, so this will be plus 1 is equal to 0. Now, the 2 and the 1 are like terms. That's going to make a 3. And I'm going to put everything in decreasing exponent order. That means my negative tangent to the 4th power has to go first. So I have negative tangent to the 4th power. Next comes my positive 2 tangent squared x, and then the plus 3 that I spoke of. For factoring purposes, I don't like having a negative in the front. So I'm just going to divide everything by -1, which just will change all the signs. So this is going to give me tangent to the 4th power minus 2 tangent squared minus 3 is equal to 0. Now it's time to try to factor this. Tangent to the 4th power will easily factor as tangent squared times tangent squared. Just jumping over to the 3 for a minute. 3 is only going to factor as 1 times 3. Now, inner plus outer must equal the middle. Inner, I have 1 tangent squared. Outer, I have 3 tangent squared. The middle is -2 tangent squared. So that means this would have to be a +1 and this would have to be a -3 in order to make -2. So that means that this will be +1 and this will be -3 to make the -3. Okay, double check one last thing. +1 times -3 is -3. Great. So we factored it correctly. Now we can use the zero product property to set these equal to 0 to find the solutions. So tangent squared x plus 1 equals 0. Tangent squared x minus 3 is equal to 0. All right, so this is going to give me, subtracting 1 from both sides, tangent squared is equal to -1, and tangent squared is equal to +3. Now, this is the end of the road for this one. There will be no solutions coming from this part of the equation, because you can't square something and have it be negative. Or look at it another way. If I went one step further, I would take the square root of both sides, and the square root of -1 is I. It's imaginary. So that's it for that side. So my only hope for solutions will come from this side. If I take the square root of both sides, that's going to give me tangent x is equal to plus or minus radical 3. Okay, now remembering the identities that I have memorized, tangent of pi over 3 is radical 3. So that means the reference angle is pi over 3. All right, so you should be able to picture this in your mind. You should not have to draw this picture that I'm drawing. I'm just drawing this for instructional purposes because you cannot read my mind. These are all pi over 3's. These are the 4 angles that have a reference angle of pi over 3. Any one of them is going to give me some kind of a radical 3, either positive or negative radical 3. Because I want plus or minus radical 3, I need all 4. Okay, so x equals. And the first one is pi over 3. The second one is 2 pi over 3. The next one is 4 pi over 3. And then the last one is 5 pi over 3. All right, for number 24, again, I do not like the fact that I have cosine and sine in the same problem. So I'm going to replace sine squared using my Pythagorean identities. I learned that sine squared is equal to 1 minus cosine squared. So that's what I'm going to do. So this will be cosine squared minus cosine plus 1. And this is going to be 1 minus cosine squared. Now I have all cosine, so this is going to be great. So I am going to subtract 1 from both sides, and I'm going to add cosine squared to both sides. So that's going to give me 2 cosine squared minus cosine. Now these cancel each other out, so I just have equals 0. All right, so there's going to be a GCF here. Cosine x is a common factor. So I'm just going to go ahead and bring out the cosine x. And inside the parentheses, that's going to leave 2 cosine x minus 1. Okay, now using my zero product property, I can set each one of these factors equal to 0 to find my solution. So cosine x is equal to 0, 2 cosine x minus 1 is equal to 0. Add 1, divide by 2, that's going to give me cosine x is equal to 1/2. Okay, now let's see what we've got. First of all, where is cosine equal to 0? Okay, here's a little diagram of a unit circle. Okay, cosine is an x value. X values are 0 here and here. Okay, so that is pi over 2 and 3 pi over 2. All right, now let's turn our attention to cosine x is equal to 1/2. What is the reference angle? Okay, looking back at this, cosine of pi over 3 is 1/2. All right, so that tells me that the reference angle is pi over 3. Okay, however, cosine is positive in 2 different quadrants. So I will have 2 solutions. So here's pi over 3, that's fine. But cosine is also positive in the 4th quadrant. So I need both of these, all right, because both of these angles have a cosine of positive 1/2. So I will have the pi over 3. Okay, that's the first one. But then the second one is 5 pi over 3. See if I can do my 3 a little better. And then 5 pi over 3. All right, so this is the full list. All right, number 25 is fun and interesting because it involves a double angle, cosine of 2x. So we will need to use our double angle formulas. And for cosine, there are 3 of them. So I can pick and choose. If I want cosine, I will use this one. If I want sine, I will use this one. If it doesn't matter, I usually use that one. Let's see. On the left side of the equation, I see I have sine. So I want sine on the right-hand side as well. So I will use the third version, 1 minus 2 sine squared. Okay, so that means I will have negative 3 sine x minus 1 is equal to 1 minus 2 sine squared. Great, now it's all sine. So I'm going to subtract 1 from both sides, and I'm going to add 2 sine squared to both sides. So that's going to give me 2 sine squared minus 3 sine minus 2. All right, I'm just combining my like terms there, is equal to 0. Hopefully this is going to be factorable. 2 sine squared. This will factor as 2 sine x times sine x. The number 2 will only factor as 2 times 1, or 1 times 2. Now, I will not even waste my time putting the 2 here, because if the previous step had no common factor, then neither one of these parentheses should have a common factor. So if I put the 2 here, that makes a GCF that shouldn't exist. So I go straight to putting the 1 here and the 2 here. Now, inner plus outer must equal the middle. Inner, I have 1 sine x. Outer, I'm multiplying now. I have 4 sine x. The middle is negative 3 sine x. So if I have a positive 1 and a negative 4, that'll make negative 3. So that means positive here and a negative here. Check one last thing. Positive 1 times negative 2 is negative 2. All right, so we factored correctly. Now the zero product property says I can find the solutions by setting each one of these factors equal to 0. Subtract 1, divide by 2, that's going to give me sine x is equal to negative 1/2. Add 2 to both sides, that's going to give me sine x is equal to 2. Now, that's the end of the line for this half of the equation. There will be no solutions here. And the reason why I know that is because on the unit circle, sine and cosine are x and y values. Specifically, sine is a y value on the unit circle. So the highest y value there is on the unit circle is 1. The lowest y value is negative 1. So you cannot have the sine function will never be higher than 1 and will never be lower than negative 1. So there's no value of x that I could plug in that's going to have a sine equal to 2. It's too big. So that's why there's no solutions there. So anyway, back to this one. Reference angle. Ignore the negative sign. The sine of what angle is 1/2? That's going to be the pi over 6. All right, we've memorized that. So the reference angle is pi over 6. So picture it. Okay. If the reference angle is pi over 6, then that means this angle where pi is 6 pi over 6. Okay, and this angle over here on the far right, if I double that, that would be 12 pi. Whoops, 12 pi over 6. Now, where is sine going to be negative? Sine is going to be negative in the third quadrant and in the fourth quadrant. All right, sine is a y value, so it's negative down below. So if this on the far left is 6 pi over 6, if I go one more, that's going to be 7 pi over 6. Okay, and this one over here is one short of 12 pi over 6, so that is 11 pi over 6. So those are the two solutions for number 25. All right, sine of 2x, that's going to be 2 sine x times cosine x. So let's go ahead and make that substitution right now. 2 sine x cosine x is equal to cosine x. Now it's very tempting to divide both sides by cosine, but you can't do that. Cosine x will often be 0, and you can't divide by 0. So instead we subtract and do the GCF. So I'll have 2 sine x cosine x minus cosine x is equal to 0. Now that cosine that I was tempted to cancel out, it's going to be the common factor. So I will pull that out front. And that's going to leave behind 2 sine x minus 1. Now, zero product property. I can set each one of these factors equal to 0 and solve for the solutions. So 2 sine x minus 1 is equal to 0. Add 1, divide by 2. So that gives me sine x is equal to 1/2. All right, all right, all right. Where is cosine equal to 0? Cosine is an x value, and x values are 0 on the y-axis. So that's pi over 2 and 3 pi over 2. Okay, where is sine 1/2? Well, the reference angle is definitely going to be pi over 6. All right, the sine of pi over 6 is 1/2. That's one of the facts that we have memorized. Okay, but there are two quadrants where sine is positive. All right, not just the first quadrant. Sine is positive in the first quadrant and in the second quadrant. So I need both of these angles. All right, in the first quadrant, that is pi over 6. So we'll add that to the list. But in the second quadrant, well, the far left would be 6 pi over 6. So one short of that would be 5 pi over 6. So these are the 4 solutions. All right, the last one is another double angle, cosine 2x. So we have all of these 3 to choose from. I don't think it actually matters. I think we could probably solve it using either one. Well, you know, I would pick one that only has one trig function in it. So I would either use the cosine or the sine. So I'm just going to go ahead and choose 2 cosine squared minus 1. Okay, so 2 cosine squared x minus 1 is equal to 1. So now we can just get cosine by itself. So I'm going to add 1 to both sides. So that'll give me 2 cosine squared x is equal to 2. All right, but then I'm going to divide both sides by 2. Interesting. So that'll give me cosine squared is equal to 1. But then I need to take the square root of both sides. So that's going to give me cosine x is equal to plus or minus 1, because I just took the square root. That could be plus or minus. All right, so where is x? Well, the cosine of what angle will be plus or minus 1? Well, cosine is an x value. All right, and the x value will be positive 1 right here and negative 1 over here. So that is 0, and this is pi. So we want both of those. So 0 and pi. And that is it. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.